Good afternoon, everyone. Thank you for signing up for the troubleshooting webinar for the greenhouse gas inventories for the ACUPCC. I'm going to go through a few of the questions that people submitted ahead of time and try to answer as many of them as I can. A lot of them were related to common topics, so that is convenient, but we'll also have time at the end for answering additional questions. So at any time during the broadcast, you can use the questions menu on your control panel to submit additional questions, and we should have time at the end to try to get to as many of them as I can. I guess before I begin, I just want to remind everyone that the reporting deadline for the ACUPCC is January 15th. And about half of the signatories will have a greenhouse gas inventory due on that date. So I'm sure many of you attending the broadcast today are in the situation of having your greenhouse gas inventory due on January 15th. Just to take a step back a moment and talk a little bit about greenhouse gas inventories in general. Typically, when we're thinking about a greenhouse gas inventory, we sort of narrow down to the part of the inventory where we're collecting data and using the carbon calculator to get our results. And we think that's sort of all the inventory is, or we think that's sort of what the key part of doing an inventory is. But really, an inventory is meant to be one of the primary management tools of your sustainability program, something that you want to look at year to year to year and be able to track over time in a consistent method to be able to understand how your sustainability program is doing, if you're being effective, if the projects that you've chosen to do are having an impact on your campus sustainability as a whole. So it's something that when you're constructing your inventory process, you want to take a step back and think a little bit about that of, how can we set up a process that's easily replicated year after year after year after year? How can we take the data that we gather from the inventory and the results that we get from calculating our carbon to start to identify key areas on campus where we need to make some adjustments to our current practices to become more sustainable over time? So the inventory process is really a little bit bigger than just collecting the data and calculating your emissions. So it sort of needs to fit into your larger sustainability planning and to be kind of a major indicator of how you're doing overall, rather than sort of an individual project or a chore that has to be kind of completed. It should be something that it's just sort of routine that happens from time to time to check in on your progress and how you're doing. So another thing that I want to mention is that the campus carbon calculator is typically the tool that is most often used for the step in that process on the previous slide of calculating the emissions. This is the most common tool used by most of the signatories of the ACUPCC, and it's a great tool because it's specifically focused on the campus scale. And was developed specifically for universities and has specific tools in it for reporting to the ACUPCC. So this is a great tool to use. It had previously been maintained by a nonprofit organization called Clean Air, Cool Planet, but it is now part of the University of New Hampshire Sustainability Institute. And all of the support and resources, if you have technical questions about how to use the Excel sheet or how to log on to the online version of the calculator or anything like that, all of those questions and user support are now managed by the University of New Hampshire. And there is also a new version of the Excel tool available right now that you can download, and that has the ability to conduct inventories through 2014. And they'll be updating it next year to allow the people to conduct their inventories for 2015. So that this is the link to that. So if you don't have the latest version of the tool, I would recommend going to download the version 7.0 if you're not already using that of the Excel version. Next slide. So there were some questions about sort of what are some common ways to conduct a greenhouse gas inventory, and what what is the advantage and disadvantage of each. So I listed three common processes here. And I think the only thing I would want to say about this is to take a look at it and think about which process makes the most sense for your campus and the resources that you have available. Student projects are very common. It's a great way to get students involved in your sustainability efforts, to get students to learn very valuable skills about becoming sustainability professionals in their careers and learning something about climate science in the process. And it's a great time scale because it typically takes about, on average, sort of a semester is a good window of time for conducting a greenhouse gas inventory. And you can do it much faster than that, but if you sort of plan out a whole semester, that gives you plenty of time to really dig into all of the details and work with students. The main disadvantage of working with students is that you don't have it's not easily replicated, the process from year to year to year. Students leave, they've lost the connections to the people who have provided them with data. The new group of students needs to be retrained in all of the methods of conducting the inventory, things like that. So while it's a really great way to get an inventory done, there is a little bit more thinking required in the process of, who is going to be the person that maintains continuity of the project year to year to year, who's going to be the person who trains the students how to conduct an inventory, who is going to be the person who introduces the student to the people on campus who will be providing them with the data, and who will monitor the results that the students produce to make sure that they're consistent year to year to year and they're using the same methodologies and the same sources of data and things like that. So while it's a great tool, it does require a little bit more planning up front than just doing the inventory within the staff of a sustainability office or institutional research or the facilities department or something like that, or hiring an external consultant. Next slide, please. And as I mentioned, sort of a semester is a good window of time, but here's an example of sort of a timeline for getting an inventory done that kind of condenses it down into just 6 weeks if you're trying to do the inventory as quickly as possible. And this would be sort of assuming that you had someone who was, working in a sustainability capacity full-time, but they were doing, all of their other work in addition to the inventory, and they were, dedicating a certain number of hours out of their week to working on completing the greenhouse gas inventory in addition to everything else that they were working on. Typically, reaching out to people around campus and collecting the data and verifying it and things like that can take about 6 weeks. And also I've noted here that once you've submitted your report, there's still some work that you would want to do with the inventory once you're completed with the data calculation piece of it. You want to publicize the results, maybe create a report to share with your senior leadership on campus, and things like that. So that can all be done after the report has been completed and submitted publicly to the ACUPCC. Next. A lot of questions were sort of about, well, what goes into an inventory? What kind of data do I need to find? Things like that. So this is sort of a high-level overview of what the components of a greenhouse gas inventory are. They're typically broken into 3 scopes. And the reason for doing that is these scopes represent, on the one hand, the amount of specificity in the emissions calculations. Scope 1 emissions are directly calculated from fuel consumption, whereas Scope 3 emissions, on the other hand, have a lot of estimates that go into them, and Scope 2 is somewhere in the middle. There's, you know exactly how much electricity was purchased, but there's some estimation of, well, where was that electricity produced and what's the fuel mix on my grid and things like that. There's some sort of averages and estimations that go into that. So Scope 1 is very, very specific. Scope 3 is a lot of guesswork and estimation, and this is our best estimate of things. So that's one reason for breaking them into scopes. The other is the sort of level of control that you have over them as a campus manager. Scope 1 emissions are things that happen directly on your campus, and you have a lot of control over those. The decisions you make about what fuels to use, how efficient your buildings are, what types of vehicles you drive on campus, things like that directly impact Scope 1 emissions. Scope 2 emissions, you have very little control over, what your electric utility is using to produce your electricity, but you have a little bit of control in that you can reduce the amount of electricity you need to purchase by generating more of it on campus, or by being more efficient overall and using lesser electricity. So you have somewhat a control over Scope 2. And Scope 3 is sort of induced. They're things that happen generally outside of the university's control, but are induced by the university's actions. So you have some limited amounts of control over them, that you can try to do things that influence the behavior of your students and employees, your subcontractors, your waste handlers, things like that. But in general, they're things that happen off campus that you have limited control over. So we try to break them into scopes to make those things very clear, and help people understand how their emissions are being generated. Next slide. In terms of the data that's required, we have a document that is just a couple of pages long. It's a nice little checklist to go through and figure out exactly what pieces of data you need to calculate your inventory. And it also has some notes and guidelines about where you can typically find that data on campus. This data might come from a registrar, this might come from your facilities energy manager, this might come from a parking department or a business office, or things like that. So they just have a lot of ideas and suggestions of people on your campus that you might want to try to reach out to get some of that data. Next. And then just very briefly, this kind of summarizes that document that I just mentioned, but the very basic, most simple things that you need to get hold of to do the very basic requirements for an inventory are sort of how much fossil fuels were consumed on campus. So this, is like natural gas and fuel oil and coal and things like that in your campus heating plant or boilers. What the vehicles that the university owns are consuming, in terms of gasoline, diesel, and then the agricultural activities. If you're a large agricultural institution, that can be a significant portion of your inventory. But if you're, say, an urban community college, you probably don't have to spend a lot of time thinking about your agricultural program. And in terms of Scope 2, for the most part, it's primarily how much electricity you've purchased. Scope 3 emissions are very broad. You can spend a lot of time calculating a lot of different types of Scope 3 emissions, going through the life cycle of the food consumed on campus, the construction processes that are happening, how much fuel is being consumed by construction vehicles that are coming to campus over the summer, things like that. So this can be a project that keeps expanding and expanding and expanding. So one of the key parts of thinking about doing an inventory is reducing Scope 3 down to, what are the critical things we really want to measure in our Scope 3 emissions? What are sort of the most important things that we will be able to have an influence on year to year to year through policy, rather than, say, the emissions induced by a construction project might be one-time emissions, and it might be interesting and useful to account for them if you wanted to offset them, or to work with a construction company that would think about reducing their emissions or something like that. But it's probably not something that you are going to be tracking year over year over year to see how the changes in your university's policies are impacting these Scope 3 emissions. So I've listed here 4 common types of emissions that are sort of the ones that are usually fairly easy to get hold of on a campus and are sort of important to measure in terms of their impact on the campus, and also the impact of policies that the campus could enact to be able to have an impact on these emissions. The ones with an asterisk, the faculty, staff, and student commuting, as well as the faculty, staff, and student air travel, are the ones that are required by the ACUPCC. When the original commitment was drafted, the people who were the creators of the original commitment were thinking of all of the different types of scope 3 emissions and trying to figure out a balance between, trying to measure everything and then measuring things that make sense for a campus to measure that are important sources for a campus to track. And so that they sort of decided that these were two of the things in scope 3 that are very important for all the signatories to track. The reason for that primarily with air travel is because it can be a very large source of emissions. Even at a very small college that has very small emissions overall, a very large portion of their emissions might come from their air travel that's been financed by the university. And commuting is important because it's probably the thing in scope 3 emissions that university policies have the most impact on. Universities can control how many students live on their campus, what types of parking passes they issue, if they issue any transit subsidies, things like that. So there's a lot of transportation demand management initiatives that a university could undertake. So there is a lot of control over commuting that a university can try to exert. So that was the reason why scope 3 was chosen to be included as one of the requirements. The two others that I've listed, solid waste and wastewater, I think are important because, typically those water conservation and recycling and things like that are often very visible things that happen on campus, things that students really connect with and care a lot about, and that a lot of sustainability programs spend an awful lot of time working on. So it's important to be able to track those things in terms of their emission impacts, and to connect your sustainability campus initiatives to your other waste and water initiatives that are happening on campus. And also those are typically, fairly easy to track. They can be complicated, like all scope 3 emissions. There is a lot of complication that goes into it, but a lot of campuses have access to their water or sewage bills if they are connected to a municipal water utility, or if you have a contracted waste hauler, they can often make at least an estimate of sort of how much trash you've disposed of over the course of a year. A lot of the questions related to, how do we go about estimating our commuting emissions? How do we do that, and what are some best practices and tips for doing that? So this here is the overall thing to keep in mind of what it is you're trying to estimate. And remember, this is scope 3, so we're talking about estimates here. You're making your best guess. There's a lot of estimations and guesswork and things that go into this calculation, and that's fine. That's the nature of a scope 3 emission calculation. But what you're looking for, you're trying to calculate total vehicles miles traveled in a year to and from your campus. So the components of that, the things you need to know to be able to multiply these factors together to get the total vehicle miles traveled, are sort of the number of people coming to and from campus in each mode. So how many people are walking, how many people are driving in a vehicle, how many people are coming by bus or train or bike. You need to know on average how far away is a person coming from, and how many times do they come to campus in 1 year. So there's a lot of ways to go about estimating this type of data. The number of commutes per year is typically something that you can estimate based on your academic calendar and by making some general assumptions of, students typically come to classes on a Monday, Wednesday, Friday schedule. So, we're going to assume that they come 3 times per week during the academic year, or, maybe they come every single day during the academic year. You can sort of make those assumptions and guesswork based on your knowledge of your campus and your behavior of your students. It's most important, though, since this is a Scope 3 calculation and there's a lot of estimation, to be very upfront and record exactly what estimates you made and why you made them, so that the next person who comes to conduct your inventory, or someone who's viewing your inventory from outside of the campus, will understand how you arrived at the numbers that you arrived at. Next slide. So the typical way to get at the vehicle miles traveled is by conducting a survey of students, faculty, and staff to ask them those questions directly. But if you don't have time for a survey, surveys can be very time consuming, and also, there's variability in the types of data you get from a survey. Are people often misinterpret how far away they live, or how long it takes them to get to campus, or they sort of overestimate the number of times they take transit rather than driving, things like that. So, again, it goes into the whole Scope 3 of this is an estimate, a best guess. But what if you didn't have time to do a survey? And certainly, a survey is not something you would want to do every single year. Even if you're tracking your emissions overall every year, conducting a survey every year is probably too much work. So survey might be something you do every 3 years, every 5 years, and then kind of interpolate the results in between the years that you do surveys. But if you're not doing a survey, if that doesn't make sense for you, if you don't have time to do that or the resources, there's a lot of things you can do to try to estimate the things that are required for calculating vehicle miles traveled without going through a whole survey process. So you can look at a lot of data that might be available around your campus, like the number of parking passes that were sold, the number of students who live on campus. If you're able to collect the zip codes of employees from the Human Resources Office or something like that, you can easily estimate average distance based on how many people live in each zip code. And then, you don't even need people's names or any kind of personal information, just, the zip code and how many people live in that zip code. So things like that can really help you make a quick and dirty estimate of what your commuting emissions should be without going through the whole process of asking everyone on campus about their commuting behaviors. The census data also, the Census Department also collects data on average commute distances, so you can try to see if there's some good estimates for your area and just base your average commute times on that. And Scope 3 also it's a great area of a inventory to, maybe the first time you do an inventory, you just make a really rough estimate. And then as time goes by, as you get better and better at doing your inventories, more familiar with the methodologies and processes, you can start making better estimates, more specific estimates over time. It's not something that you need to jump into and make sure you get completely right the first time. It's another thing that's great about Scope 3 emissions is they're excellent little discrete student projects. So you might do an inventory one year and make an estimate of commuting emissions, and then the next year have a student group look at the estimates that you made and see if they can come up with a better estimate, because they can be broken off in discrete little chunks like that for an individual student project. And similarly, there were a lot of questions about air travel as well. What are some ways that we can use to estimate air travel? And again, the thing that you're trying to estimate is the total number of passenger miles traveled. And similarly, you can survey people or have them, report when they fill out a travel reimbursement or purchase a ticket, sort of what cities they're traveling to and from and things like that. But that may be too difficult a process or too time consuming. So that, again, there's a lot of data that you can find that might already be collected and recorded somewhere on your campus that will help you to make some estimates. If you know the amount of money that was spent on travel, you can use the information from the Department of Transportation or the Bureau of Transportation Statistics to estimate how many air miles were traveled based on sort of the average airfares that year and average miles traveled and things like that. The Bureau of Transportation Statistics typically tracks that type of information, so you can use their estimates to figure out how many air miles were traveled based on the amount of money that you spent. You could also, if you don't have that and an aggregated report out of your business office or something, maybe if your university credit cards are supplied by a company, an external company, they might be able to give you a credit card report of, how much was charged to, each of the major airlines or something like that on the credit card. So that is a method that has worked for several universities. And some universities also book all of their travel through a single travel agency, and that agency might have recorded maybe the destination cities of the air travel, or they might have recorded how much money was spent in total, and then you can go back to using the BTS estimates to calculate air miles based on dollars spent. So those are just a few things to help track Scope 3 emissions in the event that you don't have a full survey or reporting of the total miles traveled. And then there were some questions about actually submitting reports. And we have a video available on our YouTube channel that walks you through the process of connecting to the ACUPCC reporting system website and going through the process of calculating of uploading your report. And here are some of the key resources that we have available for helping you conduct a greenhouse gas inventory. So the ACUPCC implementation guide and specifically the greenhouse gas briefing are two reports that we've produced for signatories that walk you through this process, as well as that data requirement that I mentioned before. And here's my contact information and two of our websites for finding resources about reporting, and the actual reporting website for connecting to you and submitting your reports. If you're having any difficulties accessing the reporting system, if you've lost your password or this is your first time going into the reporting system and you don't have an account yet, you can email the reporting@secondnature.org email and someone will help you get access to the system. So we have about a half an hour left to answer any additional questions that people might have. So if you have any additional questions to add to the question chat, please enter them into the code. These slides will be available. We'll probably make them available tomorrow and send a follow-up link to the people who registered for the workshop as to where you can find the slides. Someone asked a question about should we report on a fiscal year or a calendar year? What are the requirements for the ACUPCC, things like that. Typically, what many campuses do is they report on their fiscal year. And the reason for that is because the fiscal year in higher ed typically ends for a lot of campuses sometime over the summer, June or July. And so your fiscal year ended in June or July, and then you have from that end of the fiscal year all the way through to January 15th, the reporting deadline for the ACUPCC, to gather the data from that fiscal year, process it, do your emissions calculations and things like that. So if you're reporting on fiscal years, it gives you a bit of a buffer between when you have your data available through the end of fiscal year reporting cycle and when you have to submit a report to the ACUPCC. But that said, that is a helpful way of doing it. That's what a lot of campuses do. Many other campuses may have requirements from their state or different federal agencies where they need to report their emissions, and since they're already reporting emissions to someone else, they just want to be able to use that same report that they're already producing to report to the ACUPCC. Oftentimes the state might require them to just submit information about their Scope 1 emissions, so they just take that report of their Scope 1 emissions that they produced for the state and then add in their Scope 2 and 3 emissions to meet the ACUPCC requirements. So in those cases, they're typically looking at a calendar year, so then they report on the calendar year instead of the fiscal year. When you go into the reporting system on the ACUPCC reporting site, one of the first questions it will ask you when you're uploading your greenhouse gas inventory is, are you looking at a fiscal year or a calendar year, and what's the start date of your data? Did it start on, June 1st, 2013 or January 1st, 2014? So the reporting system will tell you, but all in all, it's up to you to choose whether you would like to report calendar year, fiscal year, whatever is easiest for you based on the data that you have available. Let's see. What are some of the other questions? Someone asked, what are the changes between version 6 and version 7 of the calculator? Typically, they come out with a new version of the campus carbon calculator every time the IPCC comes out with a new report, because they will update all of the emissions factors that go into the calculations, like as the science of climate change and the climate forcing estimates and things like that improve, the calculators improve to meet them. Also, lots of other things are updated as well in the calculator. So for example, in the piece of the calculator that's helping estimate your commuting emissions, there's a lot of data that goes into that based on the average fuel efficiency of cars in the US and things like that. That's updated every year. So they will put in the latest data on those kinds of things into the new version of the calculator, as well as adding an additional line for the new year. So typically the calculator in the Excel version will let you calculate emissions from like 1990 to the present year, and so whenever the new version comes out, they add the newest year onto that onto the spreadsheet, so you can estimate the present. Let's see, what's some other questions? If you're running into the situation where you don't think you're going to be able to meet the deadline of January 15th for reporting, you can ask for an extension. If you go to the rs.acupcc.org and scroll all the way to the bottom of that site, there's a little link there for requesting an extension. You can't request an extension for a report that's already been past due, but if your report is due on January 15th, you can request an extension at any time up until January 15th. And for a greenhouse gas inventory, an extension is 4 months, so you basically get the bulk of the spring semester to complete the report. And a lot of people do that if, say, they have a group of students working on it in a class or something, and the students need to get to their end of the class in May in order to have the report completed. So yeah, and a note as well. Someone asked a question about changing the emissions factors in the calculator. Don't be alarmed if your emissions change when you are using the new emissions factors. That is natural. It's part of the accounting process. And since the new version of the calculator will be using the new emissions factors all the way through, if you're looking at a time series of data and you're using the newest version of the calculator, it will update all of your data proportionally over all of the history of your inventory. So always when you're looking at an inventory, you want to be much more focused on what are the trends over time. Are we going up? Are we going down? How much did we go up or down in terms of percentage? And less concerned with what the actual amount of carbon on your campus is, because that will fluctuate a little bit year to year to year, depending on the calculation methods you used for calculating it. But what you want to see is a consistent downward trend over time, rather than being too concerned about what is the actual number. Someone asked a question about comparing across campuses. And yeah, we on the reporting site, ACUPCC.org, there are some statistics and data views that are accessible through the menu on the sidebar. And the best way to compare campus to campus is to look at normalized results. So, emissions per students or emissions per square foot. Or even to look at scope 1 and 2 emissions per student or per square foot. And that helps kind of make sure that you're looking at apples to apples, given all of the variabilities in scope 3 emissions, and given all of the variabilities in campuses by region and what electric grid they're connected to, and things like that. So, which is another great reason for breaking a inventory up into scopes, is it lets you kind of take a closer look at things and make comparisons that are legitimate comparisons that allow you to really see how you're doing compared to your peers. There's also some other comparisons that that we generate based on all of the data that's in our reporting system, like emissions by Carnegie classification. So then, that allows you to compare the community colleges to other community colleges, or very large state research institutions to other large institutions. Carnegie classification isn't exact parity for that, but is pretty close if you want to make sure that you're, not kind of, if you're a campus that has a lot of sort of a residential based campus, you want to sort of make sure you're not comparing yourself to another campus that is a commuter model campus, things like that. So sort of sorting the aggregated data by Carnegie class allows you to make some of those comparisons. So we still have some time left if there are any additional questions. And I can certainly talk a little bit more about the overview, sort of the process of doing an inventory in general. One of the challenges with the PCC, is the sort of need for constant reporting, and it can seem like a chore and something that's a additional burden placed on your campus. But like I said, creating an inventory that's easy to do year to year, that's easily replicable, and is something that you share broadly with your campus and talk about with a lot of different stakeholders on the campus of what it means, and that it's really embedded into part of your sustainability program as a way to track the effectiveness. That really helps eliminate some of the burden of doing an inventory every year, or even biannually as required by the ACUPCC, because you get more buy-in. You might get more support from senior administrators to help construct the inventory. There might be more students who are interested in knowing how the emissions change over time. and you could also find more people who are volunteering to help with the inventory. And it's good to build this process as you're conducting an inventory to think beyond the, getting hold of the data you need to make this calculation, but thinking a little bit ahead to next year's inventory or the inventory after that, building those relationships around your campus, getting to know the person who provides you with data, kind of talking to them a little bit about why you're collecting this data, why it's important, what you're going to do with it, and making sure that you connect with them at the end of the process to show them the results. You gave me this data and look at the cool stuff that I found out, based on making some calculations based on the data that you gave me. So really building that community of people who are engaged with the greenhouse gas inventory will really help over time lessen the burden of doing it and help make the greenhouse gas inventory also something that people care about and are thinking about and using it as a management tool, because really that's the purpose of doing the inventory, is something that helps you make decisions about how you could be more sustainable. Not, it's not meant to be a burden or, just an empty report that doesn't get looked at. It's meant to really be a tool for helping decision making. And so thinking about ways that you could better use it as a tool rather than as a project that you get stuck with, every year, pulling all this data together and making calculations and submitting a report. It's not the most exciting thing, but if you can embed the whole process into your broader sustainability planning efforts, it becomes a much more useful and rewarding tool for advancing the sustainability programs on your campus. That one back, sorry. And just a little bit more about this. I think one of the things to think about as well is in terms of campus staff, often the burden of the sustainability reporting falls to the sustainability coordinator or the sustainability director or the sustainability office staff. But taking a look at your campus and what other types of reporting have to be done by your campus and who is doing those reports is often a very useful and time-saving exercise. Universities have to report all sorts of data to all of different types of agencies. They have to report data on types of professors they have, what types of courses are being taught, how they're being taught, all sorts of things like that to accreditation agencies. And there's often people on the campus, maybe institutional research or in the dean's office or something like that, that are gathering a whole lot of data about the campus already, and connecting your greenhouse gas inventory into the process into those other existing data collection processes on campus can be very time-saving overall, as well as sort of spreading the burden around. And often you'll find that sometimes the data that you're looking for a greenhouse gas inventory isn't exactly what is being collected by someone else already on campus. Like maybe the parking department isn't collecting information on the number of students who commute to campus in exactly the way that would be useful to you. But by looking at what they're collecting already and working with that office outside of the sustainability office is a really great way to shift what is being collected over time and sort of unify people's effort and spread effort around rather than duplicating the wheel every time you try to do an inventory. Let me take a look. There's some new questions coming in. Someone asked question about previous reports on the reporting system. At any time, once you've submitted a report to the ACUPCC.org, anytime that you'd like to go back and revise the estimates of a previous report, you're able to just click on that report and edit it and make any changes or updates that you'd want to make. Some people do that routinely. Every time they do a new inventory, they go back into the old inventories and make some minor changes here and there. Other people just leave the old reports alone as sort of a historical record of what their best estimate was at that point, and just submit a new estimate. Both of them are totally legitimate ways of going about it. The going back and editing all the old previous reports is very time consuming, and you may not want to do that. The advantage of doing it is that if you look at some of the automated statistics that the reporting system generates, then they'll be consistent. And if you don't do that, there'll be maybe more of a jump in the sort of emissions. They'll sort of bounce around a little bit more when you look at your aggregate statistics through the reporting system, which is fine too, especially, as long as you sort of understand where those changes came from, that you changed your inventory methodology, or maybe the first time you submitted a report, you didn't really do all of the scope 3 emissions, and now you've gone back and added more scope 3 emissions. So the change was created by that. In terms of the new version of the calculator, that there's a new version of the Excel spreadsheet, and a new version of the online tool is coming as well, and it will be continued to be updated next year. And then UNH is working on ways to keep the tool going in the future. So looking for support and resources and things to do that. So for the time being, this is a great tool to keep using, and will keep being supported and updated through the University of New Hampshire in the same way that Clean Air Cool Planet was doing that before. Right. Yeah. If are there any, we can have a few more minutes for additional questions, but if not, I will wrap up early, and this recording will be available shortly if you want to review or go back and find the links, as well as the contact information at the end of the presentation. If I didn't get to your question, or you'd like to discuss further, or you have questions that you think of after the broadcast ends, please feel free to shoot me an email or give me a call, and we can talk through some of the specifics to your questions. All right, thanks everyone for attending today, and good luck with your greenhouse gas inventories.